Hello everyone, this is the second part of this video tutorial series for heat transfer analysis on multi-layer PCB in Abaqus software. So let's start. In Abaqus we are going to import the PCB geometry in the SAT format. It's a very nice format for Abaqus. And okay, this is our part. We can see it, the parentheses and the PCB here, the name of the part, one feature. This is the tree in Abaqus user interface, and we can also see here the module parts. We can, from this drop-down list, we can change the modules. So let's start with the partition of our model and creating the various partitions that represent the layers of the PCB. Here we have a table where we have split the 1 mm thickness PCB in the various layers, top copper, FR4, and the relevant thicknesses of each layer here. So we can use this tool here, this button in Abaqus, create partition, and we have the following options. We check here the shell, and we click extended faces. So here the Abaqus is saying select a face to be extended at the partition tool, because Abaqus recognize our part as one cell now at this time at the beginning. So the only that needs is the surface to split. So we create the first partition. So we have two cells created. So the next thing that we have to do now is to first to create a datum from this surface, enter value, flip the arrow, okay. Our table says 35 thick. The values are in 35 microns. Our values are millimeters. We're creating, so 35 it's okay. Perfect. So now we can again use this tool for the partition, but now we have to check this option, use datum plane cell. First we have to create to choose this cell, done. Now we have to select this datum, create. So the first partition has been created, and we can also see the partitions here in the tree. This is the first partition, this is the second partition. So let's move forward with the next layer of FR4, the electric FR4. 110 microns. We create a new datum, we choose this, the arrow, enter value, the arrow is down, okay. In microns, perfect. So here we click this, again, choose datum, this cell, done, and this. So nice. So now again 35. Sorry, this. Enter value, down, 35. Oh no. So we can edit this plane because we assign 35 millimeters and not 35 microns. Perfect. So now again the partition of this cell done. No, done. Datum, create partition. Perfect. So next, 640. This value, perfect. Partition, use datum plane. Nice. And one more. No. 35. Again. The arrow is down. 35. So partition, this one. Oh. Partition, use datum, this one. Perfect. And now I think it's one more 100. Yes. Enter value down. Not again the same mistake. Perfect. Use datum plane. We also have to check this and select the datum. Okay, nice. So, nice. Okay, we have created all these partitions for the PCB. One more trick that we can do for heat transfer analysis in a PCB is to somehow represent the bias that we can choose to partition our not. I'm trying to remember how we have to do this. I have done it many times. Partition faces, excuse me. Vertical and on the right. Okay, nice. So let's make some circles here, 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 and here. Dimensions 1.5, 1.5, 1.5, 1.5. Perfect. Done. Nice. So now we can do extra partition. All these done. think, yes, we have done what we want. So let's repeat it for all this. Done, extrude along. Perfect. Let's here. I know it's not an easy work, but it needs a little time to do that, but we have partitioned our part perfectly. Select the edges. Always we have to check what the Abaqus says to us. Done, along, flip, okay, create partition. Perfect. So I think that now we have made the partition that we wanted based on this information. We can move forward. Let's check a little bit here. Okay. Okay, what yellow and orange colors tell us that this is a region that can be messed with hex elements, and this is not a region that can be messed with hex mesh, but only with tetra mesh. But if we try to make some more partitions only on this part, on this partition, with extended faces, okay, now the legs of the SMD can be also messed with hex elements. Perfect. Perfect. But this cube is still tetra mesh region. Let's move forward. Nope. Let's do it again. Select the cell, done. Select the face, yes. Let's make some trials. Oh, green. Structure hex mesh, nice. So, ardent, correct direction. Perfect. 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 So now we have clean geometry that we can mess it with hex mesh for our analysis. Let's try 0.5. Let's select all the partition, standard, linear, heat transferred element. Linear, okay. This is the designation for our late elements, bricks for heat transfer, okay. Perfect. So let's mesh the part. Generate. Okay, nice. I think that, okay, it's a nice mesh that we can have an accurate analysis. So guys, stay tuned for the next steps of the analysis, the next video. Thank you for watching.